Look at this one example over here. X side 4 is equal to 9. How can we work out what x is equal to? Because that is what the end goal is. We want x and we want to get x alone. So we want something that says x is equal to something. Now we're going to be using a technique called the balancing method. And you'll understand why it's called the balancing method and how it's so important to remember that name, because it will help you a lot. If there's an equals over here, think of this as a balanced scale. What we want to do, we want to make sure the scale is still balanced, okay? So both sides of the weights are still equal. So remember that. So if we have x at 4 is equal to 9, if you want to get x alone, let's do the opposite of add 4. The opposite of add 4 is take away 4. Now since these equations are equal, since this equation is equal, we need to take away 4 on this side as well. Why? Because if you're taking away 4 on one side, you're basically taking some weight off, and the scale is going to be unbalanced, so we want to rebalance it. So we have to take away 4 on this side as well, and then we're equal again. So x at 4 take away 4 would give us the x alone, which is what we want. 9 take away 4 is 5. So our x is equal to 5. And we can check if we're right by substituting this x in. Okay, so this x is equal to 5. Let's substitute it in over here. Oh, my arrow is pointing a bit off. There. Into this x over here. If we put 5 into this x, 5 at 4 is equal to 9. And this equation does work, so x does indeed equal to 5. We can check it. Okay, so I can show you the slides just like that if you want to just check again. But yeah, x at 4 equals 9, take away 4 on both sides, you'll get to x equals 5. Now, let's look at another example. Let's say we have x minus 9 is equal to 20. Okay, x minus 9 is equal to 20. Again, we want to do the opposite. If we have minus 9 over here, we have a take away 9. What is the opposite of taking away? It's adding. So let's add 9 over here. Again, just because we want x alone. If we're adding 9 on one side, we need to add 9 on the other side to make sure that we are still balanced and we are still equal on both sides. So x take away 9 add 9 is x. 20 add 9 is 29. It's just one step because we've just literally done one step. If you have x take away 9 is equal to 20, add 9 on both sides and you'll get left with just x is equal to 29. Right, let's look at another example. Now we've got multiplication involved. So we have 2x is equal to 8. If you have 2x is equal to 8, this means 2 times x is equal to 8, right? Remember, with our knowledge of expressions, we know that 2x means 2 times x. So if 2 times x is equal to 8, if you want to get x alone, we must do the opposite again, but the opposite of timesing is dividing. And what are we divided by? 2. Because we have 2 lots of x, we want just 1 lot of x. So we divide it by 2. And we have to do that on both sides. 2x divided by 2 will give us just x, because you have 2 lots of x dividing into 2. And then 8 divided by 2 is 4. And once again, like usual, we can check if we're correct. Put this x inside. 2 times 4 is equal to 8. So good, we were correct. You can always substitute, always put your number back inside and check if you were correct. One last example, guys, and I think this one will have some negatives involved for you guys. Yes, we have 3x is equal to negative 6. If you have 3x is equal to negative 6, remember this is 3 times x. What is the opposite of timesing? Dividing. And what are we dividing by? 3, because 3 lots of x, we want just 1 lot of x, so let's divide it by 3. Do that on one side, you have to do it on the other. This will leave us with 3x divided by 3, which is x. Negative 6 divided by 3 is negative 2. Because we know that 6 divided by 3 is 2, so minus, or negative you should say, negative 6 divided by 3 is equal to 2. And we can check if we were correct by putting in there 3 times negative 2 is minus 6. Good. Or negative 6 even.